Two ice pucks, one orange and one blue of equal mass, are involved in a perfectly elastic glancing collision as shown. Orange puck is initially moving to the right at 4.15 meters per second. It strikes the stationary blue puck. It'll move off in a direction that makes an angle of 36 degrees with the horizontal, while the blue puck makes an angle of 54 degrees with the axis. This is going to be an elastic collision of two equal masses, and there's a separation angle of 90 degrees. Determine the speed of each puck after the collision. We have to conserve momentum in the x direction and the y direction. So we need conservation of momentum in the x direction. And then we're going to need conservation of momentum in the y direction. Alright, so let's write an equation for the x. They've got VOI, so that's the initial orange. We need the mass of the orange times the velocity of the orange initially, plus the mass of the blue times the velocity of the blue initially. But this is all in the x direction. Has to equal the mass of the orange times the final velocity of the orange and the mass of the blue times the final velocity of the blue. Alright, so we already know that this momentum for the blue is 0 initially. As far as the mass goes, we don't know what it is. They're equal, so they would just cancel out. We could make it like 1 kilogram if we wanted, but yeah, I mean, they're all going to be just m. I could just call them all m. And then we'll give this guy a 4.15. And maybe I'll do this. And then we'll do m times v final. VO final x plus m times VB final x. Yeah, so exactly like this is going to cancel with those. And we'll basically get it down to 4.15 equals VO final x plus VB final x. Still can't solve it though because we got two unknowns. So now we could work with the y dimension, and we could say that the initial y momentum is totally 0 because this thing is moving horizontally. So that implies that VOY is 0 initially. But over here we'll have m times VO final y plus m times VB final y. The m's cancel, and we just basically get that 0 equals VO final y plus VB final y. Now if we wanted, we could now use the angles that they're going at to find the components. So see, this is our VO final x, and this is going to be our VO final y. Down here we'll have this being our VB final x, and there'll be a component which is a VB final y. But they of course have formulas, so 4.15 will equal VO final times the cosine of its angle that it's going at, which is 36. And then VB will be going at a cosine of, let's see, its angle would be negative 54. And then we could write this VO final sine 36, and then VB final sine negative 54. The goal is to get rid of 4 different variables and get it down to just 2. See, now it's down to just 2. And now it's solvable. So we just have to plug that into an online system of equations solver where we can let one of the letters be A, perhaps, and one of them can be B. And then this can be A and B. Alright, so we may be able to just enter it just like that. Alright, so we'll have 4.15 equals A times cosine of 36 plus B times cosine of negative 54. That's one equation. The other one would be 0 equals A times sine of 36 plus B times sine of negative 54. Now I'm not sure that it's going to understand these as degrees, or it may think they're radians. I'll just type them in the decimal equivalent. So like cosine 36 is 0.8090. So I'm just going to type that in. And then cosine negative 54 is 0.5878. Alright, sine 36 is 0.5878. And sine negative 54 is negative 0.8090. See how it does on that. Alright, at least it's giving us an answer now. It shows us a plot that these equations do intersect, so there is a solution. And it should be a good enough approximation. It's saying that the final speed of the orange would be 3.36. Let's see, 30492.125 over 12499.873. 2.44 for the other one. Now I can actually, yeah, so that's the orange, that's the blue.